Properties of logarithms. When we're dealing with properties of logarithms, we often need to combine logarithms together or expand logarithms. And here we see a list of some properties that we can use to do this. The first property says that if you try to take the logarithm of 1, you're always going to get a 0, no matter what your base A is. The log of 1 is 0. And the log, whenever your base is the same as what you're taking the log of, your answer will be 1. Now, the second and the third properties you can kind of think of as being related to each other. If you take the log of something and add the log of something else to it, so we're looking at the sum of two logarithms that have the same base, we can combine that into a single logarithm where we just write it as the log of the product of these two things, the m times the n. And if we have the same thing but it's subtraction instead of addition, the converse, or I guess a related statement to that, I guess I should say, would be that you do the m divided by the n. Okay. So addition combines into a multiplication, and subtraction combines into a division. And then we have a product rule that says if we take the logarithm of something to a power, this power right here, you can pull out in front and write it as r times the log. Now let's use these properties to write these as a single logarithm. The log of x plus the log of 4. Both of these have the same base. They're both base 10. Since it's addition, I'm going to write it as the log of x times 4, which would be 4x. Here, both of these have the same base. They have a base of 3, but this is a subtraction. So I'm going to rewrite this using a division. So this will be the log base 3 of the 180 over the 20. The one that you're subtracting with the negative coefficient will be the one that goes in the denominator. But now 180 divided by 20, I know what that is. That's going to be 9. So this is the log base 3 of 9. Well, I think I can go a little bit further with that because 9 is 3 squared. So my answer here is just going to be the 2. I don't think you're going to get that from looking at the problem in its original form. But when you go through all the steps here, you see that it does simplify down to just a 2. This problem uses the power property, which says here, excuse me, I take my exponent and pull it out in front so that that exponent is now the coefficient of the log. This would be 3x times the log of 4. These are just a little more complicated. Here I have an exponent, I'm sorry, not an exponent, a coefficient that I'm going to move to the exponent. And I have a radical. Here I have a coefficient that I can move to the exponent. I also have a subtraction, which means I'm going to convert this to division. So let's see what I can do here. Let's think about the square root of 3x. Remember that anytime you have a square root, that's the same as using a 1/2 power. So first I want to rewrite that square root as 3x to the 1/2 power. Then I want to take my coefficients that are out here in front and move them to the exponent. So this will be the log base 4 of 3x to the 1/2 power raised to the 15th power minus the log base 4 of x to the 5th power. Now, I know with exponents, I can multiply these exponents together. So let me go ahead and do that so that I can write that as the log base 4 of 3x to the 15/2 power minus the log base 4 of x to the 5th power. Now, because it's subtraction here, I'm going to write it as a division. 3x to the 15/2 power over x to the 5th power. Let's see if I can simplify the exponents here a little bit. This would be 3 to the 15/2 times x to the 15/2 over x to the 5th power. Now what happens here is because these have the same base, I can subtract my exponents. So the 3 to the 15/2 power would stay the same. But 15/2 minus 5 is the same as 15/2 minus 10/2. So this now becomes x to the 5/2 power. Now, in the next problem, this is an addition. So this becomes a multiplication. I want to multiply the x plus 8 times the x minus 8. And here, I can FOIL that out to get x squared minus 64. So this becomes the log of x squared minus 64. Now I can do the same, use the same properties to expand logarithms. Here I have the log of 110 times x squared. So I can break that apart into the log of 110, the base is 8 on all of these, plus the log base 8 of x squared. Now I can use my property one more time with this exponent and pull that out in front. So I'll have the log base 8 of 110 plus 2 times the log base 8 of x. And this would be the expanded form. In this next example, I have a natural log. It's got a radical in it, so I want to rewrite that using the exponential form. The natural log of 7x raised to the 1/4 power. So I can break this apart into the natural log of, let's think of this as 7 to the 1/4 power times x to the 1/4 power. So that I have the natural log of 7 to the 1/4 power minus the natural log of x to the 1/4 power. And then I can just bring the 1/4 for each one out in front. So I have 1/4 natural log of 7 minus 1/4 natural log of x. The change of base property allows me to find logarithm values. Let me move my calculator here out of the way. When our base is not a base of 10 or a base of E. So we can use this property to help us put things into our calculator. Finding the log base 5 of 8 without a calculator or a table of values would be very hard to do, because I don't know, and I can't find in my head the power that I have to raise 5 to get 8. 5 to the first power is 5. 5 to the second power is 25. So I skipped right over 8. So what I can do to find this value in my calculator is to use the change of base formula. The change of base formula says that you're going to rewrite this as a log of 8 over a log of 5. Now I can use log base 10, or I can do natural log of 8 divided by natural log of 5. And by doing this, let's see, log of 8, got to be sure I close the parentheses in my calculator, divided by log of 5, close the parentheses, gives me 1.292. I'll just go 3 decimal places here. If I do the same thing with the natural log button, notice that I get the same value. Now let's look at this problem. Here, before I start putting stuff in my calculator, I notice both of these have log base 2, so I can combine them into a single logarithm. This would be log base 2 of 12 divided by 4, because it is a subtraction. So that would be log base 2 of 3. So what I want to find in my calculator is the log of 3 divided by the log of 2. Log 3, close parentheses, divided by log 2, close parentheses. This is 1.585 if I round it.